All right, solve by graphing. Our second example of this, so we're going to solve both equations and see where they cross. So our first equation, y equals negative x plus 1. It's already solved for y, so that's nice and easy. We can identify the slope because this is slope-intercept form. The slope is in front of the x, so a negative is a negative 1. Let's go ahead and put a 1 on the bottom so we have our rise over our run. And then our y-intercept is that ordered pair, well, it's the 1, the b value, so 0, 1. I'm going to go ahead and put that on the graph. So starting at 1 on the y-axis, and then a slope of negative 1, so down 1 to the right 1. We're just going to fill in our whole graph with these points. And then draw it in as nice and neat as you can. Okay. Our second equation, y equals negative x minus 2, it's already in slope-intercept form, so our slope is the negative in front of the x, so negative 1 over 1, and our y-intercept is that negative 2, so 0, negative 2. All right, one thing I want to point out here, I can see this slope is negative 1 and this slope is negative 1. They have different y-intercepts, so they're not the same line, but they have the same slope. So in our last chapter, what did we learn about lines that have the same slope? Hopefully you remember we figured out that they are parallel, but we still have to graph this. So starting with a y-intercept at negative 2, now we do our slope of down 1 to the right 1, and just fill up your whole graph with those lines. Draw it in. So we just said that the lines were going to be parallel, and we graphed it, and that's accurate. So what's the solution if your two lines end up parallel? Remember, a solution is where your lines cross, so they're never going to cross. This is why this would be a no solution. Or you can use that symbol. It means the same thing.